Okay, this video we're now doing a cable selection based on maximum demand. So this question here, you can see that they've given us a maximum demand of 330 amps, X90 being 90 degrees. We have two 3-core cables, so we've got two 3-core cables together with a maximum demand of 300 amps connected in parallel. The cables are protected by a circuit breaker, all right, and installed touching, right, which is that there, directly in the ground at a depth of 0.5. 0.5 is table 28, installed in the ground at 28.1, so that's a derating of 1, so we don't need to do anything with that. Thermal soil resistivity is 1.4, which is table 29. Our normal one is 1.2, so that is a derating. And then, so neglecting voltage drop would be the size of the cables. So we're not actually looking for current, like the last one, of the size of the cables for which form this circuit. And what would be the effect if the cable size, what would be the effect of the cable size if it was 1.2? So that we know that that derating is 1. All right, that's normally for derating of 1. So, spaced 300 mil apart. All right, so we've got a bit of a difference of things. So just to get back to what we need to do at the start, we know, so my bit of a thing, this one's a little bit rougher, but what we're doing is we've got the number of circuits, all right? So for example, 330, all right? Here, divided by 2 circuits, all right? Makes it 115 amps. Just changing this one because this is from another question. So what we always have to do, the first part of this here is the 330, is we need to divide it by the number of circuits. So example, 2 or 3 circuits, we divide it by the number of circuits. So we've gone from 330 down 330 divided by 2 circuits. We got 115 per circuit. Now, the next thing we got is with the 115 is we need to divide it. While we're dividing is when you divide with maximum demand, it actually sends the current up, okay? And then, so it's basically, if we look at this, we have our maximum demand as our main part of the cake. And what toppings we're gonna put on top are our deratings, okay? Once we have that, then we select the cable size. So once we know what that is, we can then go and select our cable size. Some of the teachers show, oh, go and pick a cable, come back, do the deratings, back and forth, back and forth. This way here, you get your answer, you go and pick the cable straight away. All right, it's a winner-winner chicken dinner situation. So we're gonna have a look at that now. So what I've done now, the only other thing is the deratings. Once we've got our cable size 115, these here is what we have to apply. So the two that I've got on this one is soil resistivity, right, is equal to 1.4, all right, CM/W, and that's table 29. And the other one is touching. Now, the way this question's set up is I've got 2 cables touching in the ground, and the other one is spaced 300 mil apart. All right, so my 115 amps. Now, the only thing I need to do is look up soil resistivity, table 29, so I'll go to that. Table 29, look at it where we got. So 1.2 is 1, and we're doing a multi-core because the question says 3-core. So that to me is multi-core, which we're doing here, buried in cable direct in the ground, 1.2. The one we had is 1.4. So 1.5 is the next one. So 0.92 is going to be the first derating. Okay. So let's have a look at that. That comes back to 0. So we're going to go to 1.5, which is equal to 0.92 for the derating. All right. Now the next thing we got is touching. So we need to actually look up the size cable. So let's go to 3.1. We're buried directly in the ground, right? Buried directly in the ground. That's what it says here. I've got a multi-core. I've only got 4 to choose. Item 4, 3 core, 0.5 metre in the ground. First table, 75. Second table, 90. Aluminium, copper. So I'm going to go table 14 for my cable. Right, but we can't pick that yet because we're going to have to do our derating. So cable is table 14, column 23. All right. Now we have 2 cables, so I'm going to have to do the 2 derating for that. So have a look over here. We have table 25.2 for touching. All right, so this is our soil resistivity. Touching is equal to table 25.2. All right, we'll go and have a look at that. And then we've got 2. So we've got touching and spaced, which is table 25.2 as well. So we'll have a look at that. And the soil resistivity down here is 1.2, which equals 1. All right, so 115, we'll go to table 25.2. Let's have a look. 23, cable trays. 25.2, we have touching 2 circuits. Number of circuits 2, touching 0.81. So 0.81. Here we have table spaced at 300 mil apart, 0.91. If we have a look here, 0.3 is 0.91, 0.91. Okay, so let's do the maths over here. 115 divided by 0.92, which is my soil resistivity, times, in brackets, 0.81, right, close. So we'll get my calculator over here. Let's do it on the calculator. We have 115 divided by, open brackets, 0.92 times 0.81, close brackets. Notice I've times it. Like I said in the other video, you don't add them, you times them, all right? And we get an equal sign, I get 154. So my new current is 154.32 amps. Let's do this one. 115 amps divided by 0.91 times 1. That's my spaced, right? This is my soil, because 1.2 equals 1. So let's do that one. 115 times, open bracket, 0.91 times 1, close the bracket, equals 104. Whoops, did that wrong. Let's do that again. 115 divided, sorry, because when I did one times, I went down. We got to go up, times, divided by, open bracket, 0.91 times 1, and let's go back a bit, 0.91 times 1, close bracket, equals 126. So we've got 126.37. Now, that's my 2 values for one size cable and the other. So now I need to go to table 14, column 23. So let's do that. Table 13, table 14, table 15, column 23. what did we say? Column 23. So I'm going to come down here. The first one we got is 154. So 35 mil equals 172. So 35 mil squared equals 172 amps. I can't go lower than that because it goes to 143. Coming a bit closer. 172 versus 143. I can't do this one because it's too low. I've got a minimum of 154. So I'm going to 172. Now that's 35 mil. But the next one, I can actually go to 25 mil squared, because if we have a look over here, 143 equals 25 mil squared. So we've got two different cables. So that equals 143 amps. So the difference between the two cables, space them 300 mil apart. Yes, there is no soil resistivity in this one, it's 1. There was 1.5 on this one. But 154 versus with 35 mil down to 25 mil squared. So we have two different size cables. So just to go back over, we get the maximum demand, we divide it by the number of circuits, then we divide by the number of deratings, and but you times the deratings. Deratings here are 27, 29 plus can also be the column 6 on the 3.1 to 3.4 tables, the guide tables, which column 6 tells me about if we got more than one cable. All right, so when we got more than one, that's where we use the 25.2, because we had more than one circuit, and that table told me to go there. That's a derating as well. So when you got cables touching and spaced and all that stuff, the deratings still apply with that. So you got these 5 here, and then you also have the ones where the guide tables will tell you to go to the derating. So we're 0.91, 0.81. So as you've got the cables close together or touching, it's like 0.81. But as they get further apart, the derating becomes higher and higher because you're not losing as much, you've got more heat dissipation. Anyway, we did that. We looked up the two size cables, and there we go. All right, so it's very simple. And that's what I said to you over here. I had 115 amps. Added me deratings. One came out to 154 and the other one was 126. So for the two different sizes, so we got two different size cables. One here we got 35 mil squared. This one here we got 25 mil squared. So that's the difference spacing the cables. This is 300 mil apart and this one was touching, and that's the difference. All right. Actually, sorry, around the other way. That one was touching. This one was 300 mil apart because we got less current and we got more heat dissipation. So 300 mil apart, 25 mil squared. Touching, we had to put a bigger cable in. All right. So that could be the difference in you losing a quote by size of cable. All right, guys, that's it. I'll let you go, and any questions, leave me some answers or reviews on the bottom of the page, comments and all that stuff. Put a thumbs up if you like it. I'll make more of these videos. I need to see more of that, and the more reviews I get, the better it is.